In this video, we are going to apply what we learned about proportion. So a computer animation that is captured at 30 frames per second takes 2.45 megabytes of memory. If the animation is captured at 12 frames per second, how much memory would be used? So when you are working with word problems, it's so helpful to identify and use, different colors to kind of identify the information provided, the given information. So I have in here 30 frames per second. I underlined this. And then another one is 2.45 megabytes. So they're two different information. So I just kind of use a different symbol to kind of indicate that they're different. And then on the second one, it's all about frames per second. So it's kind of similar to this one. They have the same unit, same labels. So I just underlined it. And then how much memory would be used? So we're looking for the amount of memory, so meaning we're looking for the megabytes. So we know that the answer should be in megabytes. So I gotta enclose that in a rectangle as well, similar to what I did on the first one. So this problem in here is an application of proportion wherein you have to solve for one of the unknowns. One piece is missing and we need to solve for its value. So the very first step is to set up our proportion. Now, since one of them is unknown, one of the values is unknown, we don't know the value, so we use any letter from the alphabet to represent it. So you can use A, B, or whatever letter in the alphabet, whatever your favorite letter is. But for this case, I'm going to use X. So let X equals the amount of memory. So 30 frames per second takes 2.45 megabytes. So that's our first ratio. Equals 12 frames per second from the second information over X, the unknown, which is what we're looking for. Now, when you are setting up a proportion, you have to be very careful with your units. So if you notice, I put frames per second on top, it follows that on the second ratio, I have to keep the frames per second on top. I put megabytes on the bottom, so I have to put megabytes at the bottom as well. So what if I put megabytes on top? What does it imply? What does it mean for this second ratio? It means your X here, which is in megabytes, should be on top as well. And your 12 frames per second, which should be at the bottom. Same thing with 30 frames per second, which is at the bottom. So what I'm trying to say is be consistent as to where you're gonna put up your units. Next, after setting up your proportion, the next step is to solve for the proportion. So 30 frames for every 2.45 megabytes equals 12 frames over X. So what we need to do is to multiply this diagonally, so cross multiply similar to the previous lesson. So 30 frames times X, it's here. 12 frames times 2.45, so I have 12 times 2.45. And then take note, you're trying to solve for the unknown, you're trying to solve for X, you want to isolate your X, so I have to divide both sides by 30. So 30x divided by 30, whatever you do on one side, you have to do the same thing on the other side to maintain your equality, because you're saying that they're equal. Whatever's on the left is equal to whatever's on the right, so you have to maintain your equality by dividing both sides by 30. So again, our goal is to isolate your X, to solve for X. That's why we are dividing it by 30, whatever the coefficient of X is, the number in front of X. So 30x divided by 30, so we divide this also by 30, so we multiply these two, divided by 30, and our answer here is 0.98. So 12 times 2.45, remember your order of operations, you multiply, then divide by 30. So x is equal to 0.98 megabytes for 12 frames per second. However, you're not yet done. You're not yet done. So the last step is to check to make sure that our answer is right. And how do we know if our answer is right? So go back to what we did earlier, and that was to multiply them diagonally if they're proportional or not. So 30 frames over 2.45 megabytes equals 12 frames over 0.98 megabytes. So there's a question mark there because we don't know if they're equal to each other. So if you multiply them diagonally, these numbers, my product for 2.45 and 12 is 29.4. 30 times 0.98 is also 29.4. They are equal to each other. So I'll put a check mark here because they're equal to each other. In other words, our answer is correct. So for 12 frames per second, it takes 0.98 megabytes.